Hi guys, so I wanted to do this video to show you one more time how to balance chemical equations for those of you that are still struggling. So given the equation Al plus HCl forming AlCl3 plus H2. Okay, just to recap, this is a single displacement reaction where hydrogen is being replaced by aluminum, and now we're producing hydrogen gas and aluminum chloride as the products. So in this question here, we start by listing all the individual elements that we have. We have aluminum, we have hydrogen, and we have chlorine. So on this side of our paper, we're gonna write everything that's on the reactant side. This is the reactant side, and everything on this side, it's gonna be what's on the product side. So here we have one aluminum, one hydrogen, and one chlorine. On the product side, we have one aluminum, 3 chlorines, and 2 hydrogens. So we see that our hydrogens or our chlorines are not balanced, so we must go and fix that. So in this question here, we can either start with either one of them. They're both going to be, they both need to be fixed on the reactant side. So we can multiply this side here by the hydrogens by 2. That 2 is now going to become your coefficient, or the number that we're going to place right in front of your hydrogens, or in this case, the molecule that has the hydrogen. So that's also going to modify how many chlorines we have. So we don't have 1 chlorine anymore. Now we have 2 chlorines. Okay, so now we see that we have 2 chlorines on the reactant side and 3 on the product side. We're going to have to find the common factor between them that will make them equal to each other. So in this case, in the reactant side, we'll have to multiply this side here by 3 because 6 is the common factor between 2 and 3. So now because I'm multiplying that side, this one here by 3, we see that chlorine is actually the one element that's attached to hydrogen. So that's also going to modify how many hydrogens we have. So in this case, we're going to have to fix what we just did for the hydrogens. So now we used to have a 2. Now we're going to change that to a 3, but because we already have a 2, we have to multiply the 2 and the new coefficient, which is the 3, and that's going to make 6. So I no longer have 2 of those hydrogens. Now I'm going to have 6, okay? So we can go ahead and scratch that off and then say that we have 6 hydrogens. Okay, so now we have fixed our reactant side. Let's go ahead and fix our product side. So in our product side, we've now need to multiply those chlorines by 2 so we can make them equal to the reactant side. So that 2 is going to become the coefficient in front of my compound that has the chlorine. So in this case, it's going to be my aluminum chloride. So that 2 is going to go right here in front of my aluminum. And now that's going to change how many aluminums we have. We don't have 1 aluminum anymore. We have 2. So we can go ahead and go to back to our reactant side and fix our aluminums. So in this case, now that 1 aluminum, we can multiply that side here by 2. And that's going to make it equal to each other. That 2 is going to become the coefficient right in front of my aluminum. Okay, so and then lastly, we're going to have to fix our hydrogens. We had 6 hydrogens on the reactant side. We should make it, we have to make it to 6 hydrogens on the product side. So we're going to multiply this hydrogens here by 3. And then that 3 is going to become your coefficient right in front of the hydrogens. Okay, don't forget hydrogen is diatomic. That's why we had to put that little 2 there. Okay, so our overall equation becomes 2 aluminums reacting with 6 HCl's or hydrochloric acid, forming 2 aluminum chlorides and 3 hydrogen molecules. I hope that helps.